The sun is the most noticeable and significant feature in our daytime sky, and despite it appearing fairly similar to us most of the time, our view actually does change throughout the year as the Earth orbits at closer and farther distances from its host star. Still, those changes are nothing compared to what we would experience if we could stand and view the sun from every other planet in the solar system. This is Unveiled, and today we're answering the extraordinary question, what does the sun look like from other planets? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. The sun is so big that it can be difficult to comprehend. If we consider the combined mass of every planet, moon, and asteroid currently orbiting the sun, well, the sun itself still accounts for 99.8% of all the mass in the solar system. Next to our central star, everything else is frankly tiny. Jupiter is by far our largest planet, but even it is but a tiny speck in comparison to the sun. However, since the Earth is an average of 93 million miles away from the sun, what's otherwise known as 1 astronomical unit, that life-enabling orb of light usually appears to us as no bigger than the moon. And though we might forget it, the things that we know about the sun, that it's yellowish in color, it rises in the east and sets in the west, and it provides the perfect temperature for life, are not necessarily true for the other planets. So let's take a trip around the solar system and see how the other worlds perceive it. Mercury is the closest planet to the sun, and so as good a starting point as any. The sun appears larger here than it does on any other planet. Its size in the sky is 3 times as big as what we see here on Earth because it's only a third of the distance away. But its being closer also changes other properties of the sun. On Mercury, our star is 7 times brighter than it is on Earth, for example. Not only that, but because Mercury is unable to hold an atmosphere, there isn't a cloud in sight to provide some sense of relief, to give at least a little break from the constant beaming heat and energy. For this same reason, the sun also appears almost white from the surface of Mercury, as close to its true color as you'll get from any solar system planet. What's maybe most peculiar, though, is that a single solar day on Mercury is 176 Earth days, so you'd better get used to that bright and never-ending sunlight. And finally, the Mercurian sunrises and sunsets are far from straightforward. Thanks to the planet's skewed orbit, the sun appears and disappears at different points in the sky, a potential nightmare for anything trying to navigate across the solar system's innermost inhabitant. Mercury's unfiltered view of the sun is in stark contrast to Venus, though. In fact, it'd be hard to see the sun at all from the surface of Venus, despite it being closer to it than Earth is, due to the always overcast sky and dense blanket of clouds. The Venusian atmosphere is so stuffy it would block out all view of the stars at night as well. However, pictures taken by probes suggest that if the sun were visible from the surface of Venus, it would appear distinctly orange, again thanks to the planet's thick atmosphere. The sun would also rise in the west and set in the east here, due to Venus's retrograde rotation. It spins in the opposite direction to Earth. All in all though, the sun on Venus appears mostly faint and unusually easy to miss. We'll bypass Earth because, well, we all hopefully know what the sun looks like from here, and move instead on to Mars, the other planet we probably know most about. Mars's atmosphere is very thin, while the planet itself is very dusty. This combination actually means that the light on Mars is easier spread, meaning the Martian surface is quite a bright environment, despite the sun being only 40% as luminous there as it is on Earth. The sun would also only appear around 60% as large as it is on Earth, and because, with such a weak atmosphere, there's little way for the red planet to retain heat. Temperatures average at minus 80 degrees Fahrenheit. So it's bright on Mars, but also really cold. Perhaps most interestingly though, thanks to something called the Purkinje effect, the sky immediately around the sun during a Martian sunset or sunrise is blue, but a rosy reddish color elsewhere, the exact opposite to what we often see on Earth. Watching a sunrise from Jupiter or any of the other planets, however, is a different matter entirely. Since no images have actually been taken from Jupiter's interior, we can only hypothesize what the sun would look like there. That said, because the largest gas giant is also a lot further away than Earth is, we can calculate that the sun would only be about a quarter of the size in its sky, and be around 25 to 30 times fainter than here, perhaps appearing bluish in color. That's from the upper atmosphere though. If we were to venture further down, then the sun would quickly be engulfed by Jupiter's multicolored clouds. Switching to Saturn, and even the sun begins to take a back seat, as Saturn's rings would be the main focus in its sky. The sun would be about 100 times dimmer from Saturn and appear about 10 times smaller than on Earth. It'd still be a fairly distinct feature though, and what would truly set the Saturn view apart is that those massive rings would also interact with light from the sun in interesting ways, to create optical illusions like halos and sundogs, a sundog being an effect where two bright spots become visible on either side of the sun, creating a kind of triple star effect. Uranus is so far from the sun, averaging 1.8 billion miles in its orbit, that it takes more than 2 hours for the sun's rays to even reach the planet. So if you were watching the sun from Uranus, you would actually be seeing it as it was 2 hours and 40 minutes ago. At this distance, the sun is 19 times smaller than on Earth and only provides 1/400th the luminosity. We are now a long, long way from home. But Neptune is further still, and from its icy depths, our sun would be 30 times smaller than here, reducing it to just a prickle of light in the sky. Of all the planets, Neptune unsurprisingly gets the least amount of light from the sun, with it being an astounding 900 times dimmer. By now, you really would have to search for it. Finally, although Pluto isn't technically a planet, we'll take one last stop for all the Pluto fans out there. From this barren, faraway rock, you would see a sun that's 40 times smaller and up to 1,500 times dimmer than on Earth. At this distance, it's nothing more than only a slightly larger than average star in the sky. Despite this, it would still outshine every other light source and could still hurt to look at directly, a testament to just how powerful our nuclear fusion reactor in the sky really is. There's no doubting that the sun is an essential part of the sky, and its reach and influence extends far beyond Earth. And although every planet has a quite different view of its home star, they all orbit around it and enjoy the light and stability that it provides from its place in the center of our solar system. But that's what the sun looks like from other solar system planets. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.